Oh, and here I am too.
Here I am in Da Nang, Vietnam about 6 years ago. Da Nang, once a smaller town, is now a major city port located right on the South China Sea. I came here expecting fishing to be a major practice.
I mean, Vietnam's coastline spans over 3,000 kilometers. It would appear to be an ideal country to boast a strong seafood industry, including both aquaculture and open ocean fishing. However, the data was showing otherwise. Global Fishing Watch, a project set out by Google, SkyTruth, and the University of California, was meant to see how prevalent industrial fishing was around the world, who was fishing where and when. If you look closely, the South China Sea remains primarily dark, as if no fishing had been taking place.
So I couldn't help but notice a larger problem at play.
Claims over most of the South China Sea.
Breaking news this morning, a military
is calling on the Philippines.
As far as I could tell, fishing was not a simple matter.
By its powerful ally, the United States.
But it is one of the most contested maritime regions in the world.
Fishing had been affected by both natural and unnatural forces, so this got me thinking, how does oceanography affect fishing in the South China Sea?
With a maximum depth of 5,560 meters, the South China Sea is the largest deep semi-enclosed marginal sea in the Western Pacific. Ranging from the equator to 23 degrees north and from 99 degrees east to 121 east, it joins the Pacific Ocean through the Luzon Strait between Taiwan and the Luzon Island. This includes 3 archipelagos or island groups: Pratas, Parcel, and Spratly. While land formations are numerous within this region, the majority of these are rocks, reefs, sandbanks, or other types of partly submerged landforms. See, ocean waters are always on the move. The flow of the currents influences climate and living conditions for plants and animals. Even on land, changes in the energy balance between the oceans and atmosphere play an important role in the planet's climate change. The circulation of the ocean is affected by variations in atmospheric circulations. Surface currents are driven by the force of the wind pushing on the ocean surface. Most of the research has pointed out that the seasonal South China Sea circulation is mostly affected by the monsoon winds. The monsoon is classified by its prevailing strong winds and is distinctly described by a wet and dry season. It's basically cyclonic in winter and anticyclonic in summer. Specifically, the current is generated by the Ekman Drift, centered at about 2.5 meters in depth, which is westward in winter but eastward in summer.
The fundamental drive for the monsoon, both in India and other parts of the world, is that there's a large area of land which gets warm compared to the surrounding ocean. And that surrounding ocean provides the moisture which is then driving the precipitation that constitutes what we think of as monsoon.
The northeast monsoon reverses the flowing direction, and a strong boundary current is thus developed along the Vietnam coast. In contrast, weaker southwesterly winds of about 6 meters per second dominate over most parts of the South China Sea. But it's not just what is happening above that affects the sea. In the northern South China Sea, circulation is also related to water exchanges between the South China Sea and the East China Sea, through the Taiwan Strait and between the South China Sea and the Kuroshiro to the Luzon Strait.
Water exchange between the South China Sea and the Pacific Ocean is of great importance for water circulation and heat and salt budgets.
It is a completely isolated basin under 2,400 meters, with no direct water exchange to the surrounding oceans. However, its deep water property is very similar to that of the Pacific at depths around 2,400 meters, as you can see. Driven by a persistent baroclinic pressure gradient, the colder and higher density Pacific water sinks to the South China Sea after it crosses the Luzon Strait. In the end, the monsoon wind is the most important factor for the formation, maintenance, and seasonal variation of the whole circulation.
So you're probably thinking, okay Sylvia, cool, but what does that have to do with fishing? Well, if we're to take an eco-management approach to the physical environment, we have to consider both chemistry and biology.
Marine ecosystems are strongly influenced by salinity, temperature, and the flow of ocean currents. Currents affect the availability of nutrients for plant growth, and thus the availability of food for marine animals. Eggs and larvae of fish and other animals drift with the currents from the spawning grounds of nursery areas, where they feed and grow. Currents also influence where bottom-dwelling species such as crabs, lobsters, and shellfish settle as adults. Upwelling is one of the most important features of sea surface circulation studied since the 1930s. Seasonal variability is a dominant feature of upwelling in the South China Sea. Upwelling currents bring cold, nutrient-rich waters from the ocean bottom to the surface, supporting many of the most important fisheries and ecosystems in the world. Upwelling has been observed to largely contribute to the transport and vertical displacement of nutrients and phytoplankton to the photic zone, where phytoplankton blooms may occur. It also modulates the horizontal and vertical redistribution of temperature and salinity. Upwelling has also been found to affect the migration patterns of organisms, including fish across an entire basin, with serious implications for fishing operations and output. With regards to CO2, previous studies predict that an increase in atmospheric CO2 in the coming decades may result in the intensification in the eastern boundary upwelling system, which could enhance upwelling of CO2-rich deep water, thus exacerbating the impact of acidification in these productive zones. In Nha Trang Bay in central Vietnam, it was shown that coastal development, overfishing, and expansion of marine cage culture since the beginning of the 2000s had resulted in dramatic decreases of live coral cover. Surveys conducted in April to May 2013 and the same period in 2014 revealed that with an increase in distance from the outer part of the bay towards the mainland, the river's influxes and dredged areas, coral cover decreased from 75% to just 0.6%, and species richness from 63 to 5, while the abundance of microalgae increased from 0 to 56%. These numbers, however, aren't exclusive to just the bay. It is estimated that 88% of the Southeast Asia's coral reefs were at risk, with half at high or very high risk. Overfishing threatens 64% of the reefs, while destructive fishing threatens 56%. Coastal development affects 25% of reefs, and the further 20% face the impact of agriculture and deforestation. Over 90% of the reefs of Cambodia, the Philippines, Vietnam, and Singapore are threatened, as are the Spratly Islands in the South China Sea. However, annually influenced by an early summer upwelling that develops in the coastal area of central Vietnam, seasonal upwelling has been suggested as the cause of decreased thermal stress and coral bleaching incidents in different areas of not only the Caribbean and the Indo-Pacific regions, but also the South China Sea. This is a particularly important oceanographic feature because, as you can see, the majority of fish species in the South China Sea are reef-dwelling. Coral is important to fish. An important mitigating factor for the creation of favorable thermal conditions for coral reefs would be seasonal upwelling, driven by strong southwestern winds, for instance blowing parallel to the coastline of central Vietnam. Localized upwelling can be beneficial due to its counteraction of lethal sea surface temperature heating and mitigation of thermal stress by the cooling of the water. Such oceanic processes can be considered to provide a thermal refuge for reef-building corals in the western part of the South China Sea. However, not all natural events create favorable conditions for fish. The impact of the 1998 El Niño event showed otherwise. It revealed a high spatial variation of chlorophyll concentration in the South China Sea. Chlorophyll A concentrations in the summer of 1998 were the lowest among the 7 years and were particularly low in the western South China Sea. Southwesterly monsoon winds and offshore currents were relatively weaker. This anomalous event of low phytoplankton biomass and unusually high sea surface temperature will coincide with an El Niño year in 1998. The biological processes are largely controlled by the phytoplankton biomass. Because phytoplankton forms the basis of food chains and affects sea surface CO2 through photosynthesis, those oceanographic conditions exert important impacts on the dynamics of marine ecosystems. So why is this all important? Why should we care about warmer temperatures, currents, upwelling, and how this affects fish? The reality of having no fish means problems for everyone. According to the FAO, About 40% of the protein supply in the global south comes from fisheries and aquaculture. In some countries, this percentage is even higher. Rich fishing grounds, a potential for gas and oil deposits, and strategic location has caused many of the South China Sea islands to be claimed by China, Taiwan, and Vietnam, Malaysia, and the Philippines. All 5 parties have occupied certain islands or reefs, and occasional clashes have occurred between Chinese and Vietnamese naval forces. Being bordered by some of the world's most rapidly industrializing countries, as well as being located in some of the world's busiest shipping lanes, it has proven detrimental to the island's ecosystems in many ways. Proper management of these disputes to ensure stability in the South China Sea becomes a priority for the international community. There's a general consensus that the best approach for managing the disputes is for the parties to set aside the sovereignty disputes and to focus on the joint development and management of the natural resources, such as fish.